Hello everyone. Good morning everybody. Welcome to Just Get Civil channel of Unacademy and welcome to for Mission Gate 2021. Myself Soumyajit Sen. Here we are dealing with the environmental engineering. Environmental engineering. So today is the 19th lecture of this series and we'll continue our discussion of a certain chapter, that is distribution system. Before going to that discussion, just a reminder that if you don't have an Academy Learning app in your mobile or in your device, go to your Play Store, type Unacademy Learning app and install it. Install the Unacademy Learning app and go for GATE and EAC and subscribe for the plus course where you will get some personal mentor and you will get all the top educators classes. You can view all the classes over there. You can choose from them. When you are talking about a personal mentor, that is actually a personal coach to crack your desired examination. जब भी ऐसा कोई होते हैं कि आपको साथ देने के लिए एक बंदा रहेगा जो ऑलरेडी इस प्रोसेस से गुजर चुके हैं एंड he or she is actually experienced in this process, it will be quite helpful. आपका जो स्ट्रेटेजी है ये स्ट्रेटेजी को बरकरार रखने के लिए this is very important. And go for the subscription. While taking the subscription, don't forget to apply the code SEN10. Don't forget to apply the code SEN10. This particular code will give you direct 10% of the discount. Don't forget to apply the code SEN10. And we have already launched a batch Evolve for Gate 2022 in the both language English and Hindi. 20th December we have already launched. If you have not joined, join it now. Join it today itself. Don't be late. Better to start the process early. And once again, if while joining the thing, don't forget to apply the code SEN10. It will give you direct 10% discount over there. These are the upcoming batch details. Have a look on this process. Now we are going for the distribution system. Distribution system. So it's actually the continuation of the domestic water supply part. हम लोग डोमेस्टिक वाटर सप्लाई डिस्कस कर चुके हैं, जहां पे हम देखे हैं कि हमारा मोटो ऐसा है कि कहीं से पानी को कलेक्ट करते हुए जनरली इट कैन बी अ सरफेस वाटर सोर्स, कैन बी अ ग्राउंड वाटर सोर्स, बट प्रेफरेबली सरफेस वाटर सोर्स. व्हाई इट इज प्रेफरेबल फॉर सरफेस वाटर सोर्स? व्हाई नॉट ऑलवेज ग्राउंड वाटर? एंड व्हाट आर द पैरामीटर्स? क्या पॉल्यूटेंट हैं, पार्टिकल्स, उनका साइज डिस्ट्रीब्यूशन, उसका क्वालिटी ऑफ वाटर चेकिंग, उसका ट्रीटमेंट लाइक प्लेन सेडिमेंटेशन, कोआगुलेशन, फ्लॉकुलेशन, distribution, filtration, disinfection. We have already gone through that. We have gone through that to the groundwater treatment also. And finally, what we need to do, we have to distribute the water to the households. Now this distribution process requires certain knowledge of fluid mechanical system. So that is actually we are going to deal with in this chapter. We have already covered the wastewater engineering segment where certain chapters like trickling filter, oxidation pond, septic tank, disposal of sewage effluent, sludge digestion, this chapter we have covered along with the problem itself. Whereas in the process of wastewater engineering, we have not covered the problem for wastewater flow rates, design of sewers, catalyst of wastewater, and activated sludge process. Also the preliminary treatment. We will cover those also. While I will go for after completion of distribution system, that is the end of the chapter discussion of environmental engineering. Later on, what we will do, we will revise each and every chapter along with the problems. Those problems is already done. We will not go through that. In the non-watery segment also, we have gone through the solid waste management and air pollution engineering completely. those problems are also left. So after distribution system completion, in the next class, what we will do, we'll start the problem solving process, and we'll go to the first water demand problem was over, so source of water problem was also over. We'll start with the quality of water and 10 sedimentation we will do in one day. Coagulation and filtration problems we will do in one day. Disinfection and groundwater treatment we will do in one day. Distribution system along with the wastewater flow rates and design of sewer we will deal in one day. And this characteristics of wastewater along with the preliminary treatment and the activated sludge process we will do in one day. And finally we will go for solid waste management and air pollution in one day. So यही है structure अभी फिलहाल within 6-7 days we are going to complete the whole environmental engineering process. The point is distribution system when we are talking about, so मैं पहले ही आपको बोला है कि after treating the water we have to supply the water. After treating the water we have to supply the water, and the supply of water is actually concerned for the distribution system. Okay, now what is the object of distribution system? To supply water with same degree of purity as it is attained at a treatment plant with sufficient pressure. मतलब जो ट्रीटमेंट प्लांट से हमको जो वाटर पानी मिलता है उसके वहां से तो डायरेक्टली पानी हम सप्लाई नहीं कर रहे हैं, वहां से तो पानी हाउस होल्ड के पास नहीं जा रहा है. इट इज गोइंग, it is distributed through a system of pipeline consist of reservoir or many things. तो हमको एक चीज याद ध्यान में रखना पड़ेगा कि while we are supplying the water कि जो प्योरिटी लेवल हम लोग अचीव किए हैं इसके लिए आपका द प्रोसेस ऑफ दिस वन इज फ्रॉम द ट्रीटमेंट यूनिट वी हैव टू गो थ्रू दैट प्रोसेस ओनली. मतलब वो प्रोसेस के जैसे हम लोग प्योरिटी लेवल अचीव किए हैं उसी प्योरिटी लेवल पे हमको वाटर को पानी को सप्लाई करना है. एंड इट कंसिस्ट ऑफ generally 5 things: network of pipelines, distribution reservoir, fire hydrant, which will network pipelines, a lot many pipelines will be there. Distribution reservoir, which will help us in certain things, we will discuss that. Fire hydrant, where the fire that will be help us to extinguish the fire if fire accident occurs. Water meters, that is to measure how much water is being served, what will be the cost, what is everything. And pumps to carry the water from one place to another, specifically in case of the higher elevation section. Okay, now before going to the details is we need to know that requirements of an ideal distribution system. Requirements of an ideal distribution system. Water should reach the consumer with same degree of purity and sufficient pressure. Water should reach the consumer with same degree of purity and sufficient pressure. As per the IS code, Indian standard, residual pressure head होना चाहिए 1.6 मीटर से 2 मीटर के बीच, and the time of collection at consumer point. Generally, for G plus 1 story building, 7 meter head will be provided. For G plus 2, 12 meter head will be provided. For G plus 3, 17 meter head will be provided. Sorry. So this is as per the Indian standard. Okay. These are the things we need to remember. Next is, as far as possible, the sewer line should be away from the distribution line. Why? Because that sewer line should not contaminate the distribution line. As far as possible, the sewer line should be away from the distribution line. And during emergencies such as fire accident or distribution system should supply enough water, such as fire accident or repairing process, distribution system should supply enough amount of water. The system should be reliable. That means during the breakdown, supply should not be cut off from the public. That is called as the reliability of the system. Let's have a look. Now, systems of supply. Systems of supply will be of two types. We have already discussed before in the first chapter itself, when water demand and water population forecasting we are discussing. The system of supply will be of two types, that is continuous system and time independent system, where the water will get supplied throughout the day for 24 hours. An intermittent system or time dependent system, where water will get supplied in a particular time. I'm not repeating that thing, we have discussed a lot over there. Different types of distribution system is there. One is gravity system, second one is pumping system, third one is gravity pumping system. Gravity system means where the water will flow only with the force of gravity. Pumping system is only with the pumping system, and gravity pumping system, it is very much evident that it will flow by the force of gravity and pumping both, right? Now we're going for water distribution reservoir. What is water distribution reservoir? What is the job of this water distribution reservoir? That is very important to know. Certain problems are expected from that segment also. The purpose of distribution reservoir in a distribution system is to absorb the gap between demand and supply. The purpose of distribution reservoir in a distribution system is to absorb the gap between demand and supply, controlling the fluctuation between demand and supply. So रिजर्वर का काम क्या है? कभी डिमांड और सप्लाई के बीच का जो गैप है उसको कंट्रोल करना. वो कैसे होगा? सोचिए, एक पर्टिकुलर चीज मैं थोड़ा सा दिखाता हूं. लेट इट बी लाइक, अगर आप डिमांड को प्लॉट करते हो सुबह 6 बजे से लेके आपको 12 बजे तक, जस्ट आई एम गिविंग एन एग्जांपल सो दैट यू कैन अंडरस्टैंड प्रॉपर्ली दैट व्हाट इज द गैप. तो ऐसा है कि 6 बजे नॉर्मली कम आदमी उठते हैं डे टू डे लाइफ वाले, तो a certain demand, but it will keep on increasing with time. क्योंकि 9-10 बजे के आसपास almost maximum persons are going to office, schools, their commercial places. So generally, lot many water uses will be there. After 10:30, 11, a flat process will be there, and after 12, it will again get decreased. Why? So that time only household persons are staying in the houses. Again, it will increase up to after 4, and it will 6, 7, 8 around. It will again attain a peak value. It will again come down. So eventually, what you are observing, zigzag in nature. तो भैया ये तो पॉसिबल नहीं है कि एक बंदा को आप बैठा के रखे हैं और जो देख के बोल रहे हैं कि ओके अभी है सुबह 6 बजे तो डिमांड कम है तो थोड़ा बल्ब को बंद कर दें, अभी सुबह 10 बजे है बहुत ज्यादा डिमांड है बल्ब पूरा खोल दें, ऐसा पॉसिबल नहीं है. सप्लाई विल बी लाइक अ कंटिन्यूअस थिंग. So if the supply is a continuous thing, it should not be like that. So sometimes demand is more than the supply, sometimes it is same, sometimes it is less than the supply. तो जब डिमांड मोर देन द सप्लाई है मतलब आपको कहीं पे तो पानी को स्टोर करके रखना पड़ेगा वो डिमांड को सप्लाई मतलब पूरा करने के लिए. And when supply is less from the demand, that means actually there is some deficit. So you have to have certain amount of stored water which will actually getting supplied. Or when the demand is more, sorry, the supply is more, तब surplus amount, extra amount पानी आपके पास क्या करेंगे, आप फेंक देंगे खर्चा करके जिट कर किया हुआ पानी. तो उसको भी स्टोर करने के लिए जगह चाहिए. तो ये जो फ्लक्चुएशन है डिमांड और सप्लाई के बीच, इस फ्लक्चुएशन को कंट्रोल करना लायक जो चीज है दैट इज कॉल्ड एज वाटर डिस्ट्रीब्यूशन रिजर्वायर. The purpose of distribution reservoir in a distribution system is to absorb the gap between the demand and supply. The total capacity of water distribution reservoir is defined as the balancing storage capacity or equalizing storage capacity, which is actually the minimizing the gap plus fire demand plus breakdown demand. Here I have just shown you the thing what I have already discussed in the previous slide. तो फायर डिमांड ब्रेकडाउन डिमांड तो फिक्स क्वांटिटी है, हमको देखना पड़ेगा हाउ टू फाइंड आउट द बैलेंसिंग स्टोरेज कैपेसिटी और इक्वलाइजिंग स्टोरेज कैपेसिटी. एंड दिस इज फाइंड आउट by mass curve of supply and demand with time. This is find out by the mass curve of supply and demand with time. What is mass curve? From a hydrological concept you know that mass curve is nothing but cumulative plot versus time. Cumulative मतलब आगे को लेके. Just have a look. So what is cumulative supply line? It will be the cumulative supply line. The point 2 is actually along with the point 1 value. And cumulative demand line, so this is cumulative demand, will be of any type, anything. So certain cases are there. Case 1, suppose this is cumulative supply and this is cumulative demand, where this is case 2. So where, see, try to understand the thing first, then I'll go for the case 2 and case 3. So in case A, this is your demand. Sometimes demand is more than the supply, and sometimes supply is more than the demand. So there will be lot many deficit value, and there is lot many surplus value. What is balancing storage capacity? BSC is nothing but the maximum of surplus plus maximum of deficit. Maximum of surplus plus maximum of deficit. That is your cumulative supply versus demand line. Maximum of surplus versus plus maximum of deficit. Okay. So this is your maximum of deficit. This is the maximum of surplus. Now, why these maximum values we are concerned about? Nothing but, suppose in case of deficit you have to supply the water, and in case of surplus you have to store the water. तो जब आप मैक्सिमम डेफिसिट के बारे में कंसर्न होते हैं, मतलब इफ आपका डिस्ट्रीब्यूशन रिजर्वायर मैक्सिमम ऑफ ऑल डेफिसिट को सप्लाई कर सकता है पानी को, तो कोई भी डेफिसिट वैल्यू को सप्लाई कर पाएगा. और आप अगर आपका डिस्ट्रीब्यूशन रिजर्वायर जितना सरप्लस अमाउंट है, सब सरप्लस अमाउंट में से मैक्सिमम वाले सरप्लस अमाउंट तक पानी को स्टोर कर पाएगा, it will be like that. That's why we are concerned about the maximum of surplus and maximum of deficit. And BSC, balancing storage capacity, is equals to A plus B. Balancing storage capacity is equals to A plus B. In case 2, here we have seen that all are the deficit, so obviously maximum of the deficit will be the balancing storage capacity. Here all are surplus, here B is the maximum surplus value, will be the balancing storage capacity. Is that clear? Now, in exam process, they will not provide you this graphical process is not possible. So that we need to go for the mathematical situation, mathematical process. How to deal with this balancing storage capacity mathematically, I'll show you by this problem. One problem I am solving, and second problem you need to solve for a better understanding and for to get the confidence for this balancing storage capacity. The question is, a town demands 20 ml of water and the demand pattern of the town is given below. Water is supplied to 4 to 8 am in the morning and 4 to 8 pm in the evening. Find the balancing storage capacity of the water distribution reservoir. Demand pattern from 0 to 6 am, 6 to 12, 12 to 6, 6 pm to 12 am is given. The point is, the way I'm going to solve this in a tabular form so that you won't miss any data, आपके पास कोई data miss ना हो जाए और चीजें एकदम सही ढंग से चले, कोई गलती का कोई गुंजाइश ना हो. See, Q is 20 ml, time of supply is what? यहाँ पे 4 घंटा और इधर 4 घंटा, तो 8 घंटा is the time of supply. So rate of supply is 20 ml per 8 hour is 22.5 ml per hour. तो 0 to 6 am वाला कहानी में कब कितना घंटा सप्लाई हो रहा है? 4 से 8 में, 4 से 5 और 5 से 6, उस सेगमेंट में रात को 12 बजे से 6 बजे का सेगमेंट में 2 घंटा ही सप्लाई हो रहा है. तो कितना पानी सप्लाई हो रहा है? 5 ml. 6 से 12 में कितना पानी सप्लाई हो रहा है? 6 to 7 and 7 to 8. क्यों 4 से 8 बजे तक ही सप्लाई हो रहा है, तो 4 से 6 वाला कहानी पहले सेगमेंट में चला गया, 6 से 8 वाला कहानी आ गया दूसरा सेगमेंट में, अगेन 2 आवर्स सप्लाई, अगेन 5 ml. 12 to 6 में भी 4 से 5 से 6 शाम को 5 ml, और it is also 6 to 7 pm and 7 to 8 pm again 5 ml. This is the supply process. Is that clear? Yeah. 0 to 6, 6 to 12, 12 to 6, 6 to 12. Process of tabular form, percentage demand, we noted down demand. So 20% of 20 ml is 4 ml, like this. 35% of 20 ml is 7 ml, 15% of 20 ml is 3 ml, and 30% of 20 ml is 6 ml. And supply is 5 ml, 5 ml, 5 ml, 5 ml. Now, what is the cumulative demand here? 4 ml. Cumulative supply 5 ml. So supply, cumulative supply is more than cumulative demand. So no deficit is there, surplus is 1. Here 7 plus 4 11, it's 10, 5 plus 5. So demand is more than supply. So deficit is 1, surplus is nothing. 11 plus 3 14, and 10 plus 5 15. Once again surplus is 1. Now it's all at 20, no demand, no surplus. So there are only one deficit value, so maximum of deficit is only 1 ml. And there are 2 surplus value, all values are 1 ml, so maximum of surplus value is also 1 ml. So balancing storage capacity will be 1 plus 1, 2 ml. Is that clear? Just I'm putting the questions each and every slides for once. Have a look. Look at this slide carefully. Solve this question at your own. Same question: a town with a population of 60,000 supply water at a rate of 200 LPCD. The demand pattern of the town is given below. The water is supplied continuously at a constant rate throughout the day. Find out the balancing storage capacity of the reservoir. Solve this. Can I proceed to the solution? See, Q is 60,000 into 200 is 12 mld. That is population into per capita water demand. So as the water is getting supplied throughout the day at a constant rate, so rate of supply is 12 by 24, it's 0.5 ml per hour. Time, percentage demand provided, demand is there, supply is there. So 45% of 12 ml is 5.4, 20% of that is 2.4 and 4.2. 4 ml for 8 hours, 0.5 ml, that's 4 ml. Cumulative demand and supply, deficient surplus, and finally the balancing storage capacity 1.6 ml. Finally, the balancing storage capacity 1.6 ml. Clear? Now, the layouts of water distribution system. A water distribution system layout consists of certain things like main pipeline, sub-main pipeline, branch pipeline, lateral pipeline, and house connection. From main pipeline, water will go to the sub-main pipeline, then it will go to branch pipeline, then lateral pipeline to house connection. Is not necessarily all the pipelines will be there. Which one is connected with the house connection is called as the lateral. That is important. Which one is connected with the house, that is called as the lateral. Now, the distribution layouts are of four patterns: dead end system, grid iron system, circular system, and radial system or zonal system. So, dead end system is the haphazard system, also called as tree system. It is for irregularly located area. It is best for haphazard area. No proper pattern will be provided. That is called as dead end system, haphazard system. The advantage of dead end system is it is economical process. It is simple to analyze and design. It is simple to analyze and design. Expansion or extension is very easy. Expansion or extension is very easy. Disadvantage is chances of contamination at the dead end is high. During repair, supply cannot be done, and during emergencies, large amount of water cannot be demanded. Okay. So these are the advantage and disadvantage of the dead end system. Have a look. Now, the gridiron system is also called as interlocked system. They are the main pipelines, and these are the laterals. No dead end, no chance of contamination. Supply can be made during the repair also. Large amount of water can be drawn during emergencies. Whatever is the disadvantage of the dead end system will be the advantage of the gridiron system. Okay, and opposite one, costly process. Analysis and design are complex. Future extension and expansion are difficult. Note, it is suitable for cities having grid pattern of roads. As example, in our Indian scenario, Chandigarh, Gandhinagar, etc. Okay. Now, circular system where the main pipelines will be in the periphery, advantage and disadvantage will be same as the gridiron system. Radial system or zonal system is nothing but the process where the distribution system is defined by lot many reservoirs itself, and they will deal with the system. So actually, zonal system is applied where zone specification water supply will be there. Not for the whole city, the same system is there. In normal Indian scenario, this is applied nowadays because a certain city is classified according to the economic viability and economic importance. And zone specifications is there, and water supply is also defined by that particular process. Now, method of analysis. Method of analysis, this pipe system will be of three types: method of section, equivalent pipe method, and Hardy cross method. Method of section क्या है? जहाँ पे Q will be calculated is the most easiest process to find analyze the system. It is used for this dead end system. जहाँ पे Q will be estimated by continuity equation. Q equals to A into V, and head loss will be measured by Darcy-Weisbach equation. Darcy-Weisbach equation we have already seen previously in the source or conveyance of water, where Q will be calculated by continuity equation, and Darcy-Weisbach equation is FLV square by 2GT is equals to FLQ square by 12.1 into D to the power 5. D is the diameter of pipeline. This thing we know. Okay, that is in method of section. Clear? In equivalent pipe method, like the electrical analogy, where a lot many resistor will be in series or in parallel, what we will generally do, we used to take a equivalent resistor for series connection, for parallel connection. In series connection, Q will be, or discharge will be identical. See here written, Q will be equals to Q1 is equals to Q2 is so on. And the head loss will be additive. HL will be equals to HL1 plus HL2 plus HL3 and so on. For parallel connection, Q will be the opposite of the series connection. Q will be additive and head loss will be the identical. Q will be additive and the head loss will be identical for the parallel connection. That is for the equivalent pipe method. Okay. Now we are going for the most important and most complex scenario of the calculation of the analysis of this pipe process is Hardy cross method. So to analyze any kind of complex pipe networks, we have to use Hardy cross method, where head loss will be defined by HL directly proportional to Q to the power X. HL is directly proportional to Q to the power X, where X is called as pipe constant. We will see. In any balanced distribution network, it has to satisfy true hydraulic axioms. What are those hydraulic axioms? At any pipe junction, flow in should be equals to flow out, and thus that means summation of all inlet flow will be equals to summation of the all outlet flow. An algebraic sum of head loss around a closed loop must be zero. The algebraic sum of the head loss around a closed loop must be zero. So summation of head loss will be equals to zero. Clockwise anything will be positive and anti-clockwise anything will be taken as negative. Before going to solve a question from this particular segment, let's go through the process what we have discussed once. Initiative. So these are the hydraulic axioms for this. Solve this question. It's a complex network of pipeline. Some pipes are given, some flow are given, some head loss you need to find out. Solve this question. Some head loss are also provided, some head loss you need to find out. What you do? Some just let us see. The বর্ণনাই নিয়ে নাও। আপনাকে ডাকা। পাপন শ্যাম্পুটা শেষ করে দিস। আর তুই জানে না ওই জামা কাপড় নিয়ে বসিস না কোথাও। ওখানে এখন ডাক। So if you have to solve the question now, you have to take a particular junction to start. For A, if you take this junction A, see Q4 and Q5 associated with A is unknown. So two unknowns is not possible from one equation. For junction B also two unknown is there, Q2 and QB. For junction C also two unknown is there, Q2 and QI5. Only you can start with junction D itself. For junction D, Q2 is entering to the point, Q4 and Q3 is going out. So Q in is QD and Q out is Q4 plus Q3, where Q4 is unknown to us, which will be 100 minus 40, 60. So Q4 is done. Then we are going for junction A. For junction A, Q4 is entering. Apart from that, QA, Q1 and Q5 all are going out. From that we can say Q5 is equals to 10. Clear? Now we need to go for junction C because still junction B is having two unknowns. Now for junction C, Q5, Q3 is entering, Q2 and Q3 is going out, where Q2 is unknown. From there, Q2 is equals to 20. For junction B, Q1 and Q2 is entering, QB is going out, where from here QB is 50. That is the Q values. So just have a look. Now, for head loss, we need to go for the two loops. One is ABCA, 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 this loop. So, this is a closed loop where HL1, HL2, and HL5 is there. So, summation of all head loss will be 0. HL1 is clockwise, that's why it's positive. HL2 is anti-clockwise, that's why it's negative. HL5 is anti-clockwise, that's why it's negative. From here, HL5 is equals to 20. Similarly, for ACDA, HL5 is clockwise, that's why positive. HL3 and HL3 is negative because it is anti-clockwise, and HL4 is clockwise, that's why it's positive. From here, HL4 is equals to 100. Okay. Now we are going for the procedure in Hardy-Cross method. Procedure means the design procedure. Here many things are given. You need to find out some things. Now find out going for the Hardy-Cross method procedure. Just a minute. First, you need to assume the flow in each pipe such that Q in should be Q out at a junction. And according to that assumed flow, we need to find out the closed loop for head loss. If the summation of head loss, that is the all the hydroxyl axiom. One you are assume, one you will check. If the summation of head loss is 0, your assumed flow are correct. If it is not equals to 0, calculate the error delta. But delta is equal to summation of head loss by minus summation of all head loss by x into summation of h by q mod. And that is x is what? So we know, we remember HL directly proportional to q to the power x, that x is that. Now adjust the error and correct the flow. Repeat until and unless you are getting delta value as 0. Now you can ask sir that it's the iterative method problem. Yes, it's true. Why you are solving? Because this much of bigger size problem will not come in gate, but the part of this problem may come in gate, and it's coming in gate. Last year also there was a problem from distribution system of this uh, process only. Okay. Now we will solve one particular question to understand the thing properly. This is the network of pipeline. Uh, K is given. Actually, what is K? HL directly proportional to Q to the power X. So HL is equals to K Q to the power X. K is that only. But X is equals to 2 given. This is the pipeline given where 100 is coming this side, 40 is 60. What is the process? First, what we need to do? First, we need to assume the flow in each pipe of a network such that Q in at junction is equal to Q out at junction. We are doing that. Step 1. 100 dividing into two parts, 50-50. So 40 is going out here, 10 is going out. Then junction at A, 100 is coming, 250 is going out. Okay, fair enough. At A is okay. At B, 50 is going in, 40 and 10 is going out. Fair enough, done. At C, 50 plus 10 is coming and 60 is going out. So now you are assumed properly as Q in is at junction is equal to Q out at junction. Correct. variant of I'm wrong. Calendar. Calendar. Step 2. So just I'm doing the all other steps in a single tablet form, so that you are not missing anything. Try to understand. Pipe AB, BC, AC. K value is given. For AB, K value is 1, BC, K value is 2, AC, K value is 1. Assume Q. See, for AB it is clockwise, so plus 50, BC it's clockwise for plus 10, AC is anti-clockwise plus minus 50. Okay. HLK to the power X. So for this it is obviously it's positive, it's negative. So summation of head loss is coming as plus 200. That means which is not equals to 0. It's a closed loop. So your assumption is not correct. What you need to do, you need to find out the delta. And what is delta value? It's summation of HL by X into summation of mod of H by Q. So we need to find out H by Q, that is there. So mod of H by summation of mod of H by Q is 120. So you need to calculate the delta value. Delta value is this minus 0.83. So now by finding out the corrected Q value, now what to do? Corrected Q. So 50 minus 0.83 is 49.17. 10 minus 0.83 9.17 minus 50 minus 0.83 minus 50.83. So by taking all this corrected Q value, you have to go for the second iteration process. See, now you will take this corrected Q value as your Q value, and second iteration for this you will calculate all those things until and unless if your head loss value is coming to 0, summation of all those head loss value, you have to go with this iteration. Second iteration I have not solved, just for your understanding I have given the table itself. Understood? Now check it out. Vicky কৌশল ফৌশল আছে সেই দেন আনন্দ বাজার মানে এটা কুড়িটা ছড়িয়ে অক্ষর তোমার কটা করেছে না ইয়ে যে তোর ইয়ে बर्थडे होगा ছেলেবেলা ৬টা থেকে ৬:৩০টার মধ্যে যেত মাথায় থাকবে, মাথায় থাকবে। ব্যাস, চেয়ারটা আমাকে দিয়ে যা, তাহলে মনে করিয়ে দেবো। Now, different types of valves and their functions. Gate valves or sluice valve is used to regulate and control the flow in a pipe. Check valve or reflux valve or non-return valve is used to allow the flow only in one direction. Air valve or pilot valve used to remove the air from pipeline. Generally, it is provided in the pipe joints where air lock is possible. Pressure valve or release valve, it is used to release the excess pressure. Scour valve is used to remove the water from pipeline before cleaning. Okay, that is all about the distribution system. Hope you understand the thing. That is the chapter discussion of environmental engineering will be is over now. So from the next class onwards, we will go for the problem solving process. And don't forget, once again, I am giving you the reminder that don't forget to install the Unacademy learning app in your mobile and go for the plus courses. Subscribe there with the code 1010 ACN10. And this is the upcoming batch details. We already launched a batch Evolve Get 2022. For both the cases, if you are going for subscription, please don't forget to apply the code SEN10. Please don't forget to apply the code SEN10 ACN10. Thank you very much. See you in the next class. We'll start the problem solving process. Just brush up the courses. Okay. Goodbye.